Hey guys, you are welcome back to my YouTube channel. In today's video, we are going to be solving another question on sieve analysis. We're going to be solving another question on sieve analysis, and we are going to be solving this question B. This question BII. This is the question that we're going to be solving. I think this question is of recent year, which is what 2021-2022 section. So this is the question that we're going to be solving. In my previous video, you might have come across something like this, but this particular question is different. If you look at the question, you will realize that we are having two unknown, which is what x and y. So, and the first question itself say we are going to be solving for what x and y, and hence calculate the fineness modulus and what the average size of the material in this ground, which carries what 15 marks. So I want you to follow me carefully as I solved. Now, since you have this, the first thing, if you are solving this question in the exam, the first thing I want you to do is that I want you to rearrange the table. I want you to rearrange the table for more vivid solution. I want you to rearrange the table. I want you to put the table in a vertical. This is an horizontal table. I want to put it vertically, so that's what I'm going to be doing first. So I have this as my new table. Yeah, I have the mesh in this side. I have the opening size. I have the percentage of the material retained by it. So I have the new table here. Now let's proceed with our calculation. If you want to calculate the value of x and y, don't forget that they give us one equation, which is what x minus y is equals to what 9.87. X minus y is equals to 9.87. And you come back to our question, you realize that we have something like percent before, and I told you that if you heard percentage in the question, definitely you are summing up to what? You are summing the value here to 100%. That's the reason why I put 100 here. So you are summing all this to 100%. So let's proceed with our calculation. First, I want you to write out the equation and call this equation 1, because you have 200. X minus y equals to 9.87. So I'm going to be having x minus y, and put it here. X minus y is equals to what? X minus y is equals to 9.87. 9.87. This is what equation 1. And if I want to get my equation 2, I'm going to be using the percentage of the material. So don't forget, total percentage is what? Total percentage of the material retained. Total percentage of the material retained equals to 100. So I'm going to be summing all the value of the percentage retained to 100%. So I'm going to be having 0.07, which is this 0.07, 0.07 plus 5.84 plus 5.84 plus 5.84 plus x plus 34.86 plus 18.48 plus y plus 5.75 plus 2.17. So I have this. Now I have this as the total percentage of material retained equals to what? 100 what? Equals to 100. So I'm going to be having x plus y. As you know, I'm going to be having x plus y plus 0.07 plus 5.48 plus all this number. We are going to be having x plus y, that will give me 32.83 plus 32.83 equals to what? 100. So if I want to get my x plus y is equals to 100 minus 32.83. So subtract that. 100 minus 32.83. I have 67.17. That is 67.17. Oh, there is a mistake here. Yeah, there is a mistake here. I made a mistake. if you sum 0.07, 5.84, and others like that, you are not going to result into 32.83. There is a mistake here. I'm sorry. Let me see. X plus y. When you sum 0.07, 5.84, 34.86, and 5.75, and others like that, you're going to get plus 67.17, 67.17 equals to what? 100. So this is not part of it again. So we're going to be having x plus y equals to 100 minus 67.17. So x plus y is equals to 100 minus 67.17 minus. So we're going to be having 32.83, 32.83, 32.83. So you can call this equation 2. You can call that equation 2. So I'm having two equations like that, which is x minus y equals to what? 9.87, and what? X plus y is equals to 32.83. The next thing to do is to match both equation 1 and 2, combine both equation 1. So I have this as my both equation. So I can proceed to solve the value of my x and y simultaneously. Of course, this is simultaneous equation. Probably if you didn't know how to solve simultaneous equation, kindly go back to my channel and watch. I drop a video, step-by-step solution on how to solve simultaneous equation. I drop it on the channel. You can kindly go back to my channel and watch the video. Now, since I have, if you look at the signs at the front of x and x, they are the same. The sign at the front of x and y in equation 1, y in equation 2, they are different. So I can easily add up the equation and then eliminate my y to get my x. So that's what I'm going to be doing. Add both equation 1 and 2. Add both equation 1 and what? 2. So I'm going to add in the equation together. X plus x is what? That's what? 2x. 2x minus y plus y, that is what? 0. So that's eliminated already. So 9.87 plus 32.83. 9.87 plus what? 32.83. 9.87 plus 32.83, that is what? 42.70. 42.70. So x is equals to what? 42.70 all over 2. So x is equals to 42.070 divided by 2. Divided by what? 2. So you are at 21.75. 21.35 rather. 21.35. So that is the value of my x. Since I know the value of my x, I can easily get the value of my y. I will substitute the value of x into any of the equation above. Let me use equation 2. So I'm going to be having substitute x into equation 2. Any of the equation you can use. I'm using equation 2. So I'm going to be having x plus y is equals to what? 32.83. So x plus, what's my x? 21.35 plus what? Plus y is equals to what? 32.83. So if I want to get the value of y is equals to 32.83 minus 21.35. That's value of x. My y is equals to 32.83. That's 11.48. So my y is equals to 11.48. 11.48. So my x is 32. My x is 21.35, and my y is what? 11.48. So I can easily put it on my table. So my x is 21.35. 21.35. My x is 21.35, and my y is 11 point. Don't forget 11 point what? 11.48. So that's the value of my y. My y is 11.48. So that is the value of x and y. You have already gotten the value of x and y. So the next question says that we should calculate what? We should calculate the next question that we should calculate the FINESS modulus, which is what Roman figure the FINESS modulus. That's how do we calculate the FINESS modulus? Don't forget, in my previous video on FINESS modulus, I told you that the formula for FINESS modulus is the sum of the weight by fraction over what? Over 100. Sum of the weight by fraction over 100. FINESS modulus, which is what? Let me call it FM. FINESS modulus is equals to FINESS modulus equals to sum of the weights by fraction all over 100%. 100 all over 100 rather. So sum of the weight by fraction. How do you get the sum of the weight by fraction from your table? Don't forget, you need. So this is the formula for calculating FINESS modulus, sum of the weight by fraction all over 100. So if you want to get your sum of the weight from by fraction, let's go back to our table. So let's go back to our table. This is our table now. You have to know your multiplying factor. You know, in our previous solution that they solved, in the previous solution that I solved, they gave us the multiplying factor, but here they didn't give us the multiplying factors. They only told us to solve the the FINESS modulus. So, and I told you that if you want to get your multiplying factor, it's very easy. Just label the pan as 1 and as 0 rather. You put 0 in the pan, and the 100 carry 1, 2, 3, 4, 5, 6, 7. So this is our multiplying factor. So in order to get our weight, to get the weight, we multiply the multiplying factor multiplied by the percentage of the material retained. Let me call this MF, multiplying factor. Let me call it MF, multiplying factor. So to get our weight by fraction, we have to multiply the multiplying factor multiplied by our percentage of the material retained. So if I multiply 7.70, 0.07, let me call the sum of the weight by fraction. Let me do this. So let me call the sum of the weight by fraction. Let me call this sum of the weight by fraction. So 7 multiplied by 0.07. 7 multiplied by 0.07. 7 multiplied by 0.07. That will give me 0.49. 0.49. That will give me 0.49. 6 multiplied by 5.84. 6 multiplied by 5.84. That will give me. So 6 multiplied by 5.84. Let me write it. 6 multiplied by 5.84. That will give me what? 35.04. 35.04. Then I'm going to be having 5 multiplied by 21.35. So that will give me 106. 106.75. Then 4 multiplied by 34.84. Multiplied by 34.86. That will give me 139.44. 139.44. And then 3 multiplied by 18.48. 18.48. That will give me 55.44. 55.44. So 2 multiplied by 11.48. 2 multiplied by 11.48. That will give me 22.96. Then 1 multiplied by this, it will also do the same thing. 1 multiplied by 5.75. 0.75. That will give me 5.75 also. 5.75. 5. Then 0 multiplied by 2.17. 0 multiplied by what? 2.17. 0. So I have gotten my I have gotten the sum of the weights. I've gotten the weight by fraction. So the sum of the weight will be what? The total of this. You sum all this. You sum all this together. So that's what I'm going to be doing now. So when you punch your calculator, you will result into 365.38. So this total is what? 365. Let me put it down. 365. 365. Point what? 0.38. Sum of the weight by fraction. Sum of the weight. Sum of the weight by fraction equals to what? 365 point what? 365.38. This is it. That's it. 365.38. So since we know the sum of the weight by fraction, we can easily say that the finest modulus Fm is equals to what? 365 point what? 38. 365.38 all over what? All over 100. We can easily say that. So divide by 100, you get 3.6538. 3.6538. So that is our finest modulus, and the question does not stop there. The question proceeds and said we should calculate the average size of materials in this grant. The average size of the materials in this grant. If you want to calculate that, don't forget the formula that I drew up in my previous video, which is what? The D average. The D average, DAVG, is equals to what? 0.0041 into bracket what? 2 raised to the power of what? Finest modulus, which is this. That is the formula for D average. Don't forget this. So let us substitute our finest modulus. We are going to have equals to 0.0041 to the power of 2 raised to the power of 3.6538. So 2 raised to the power of 3.6538. 2 to the power of 3.6538. I have 0.0041 multiplied by 12.58, approximately 12.59. So I want to get this. So I have 0.0041 multiplied by 12.59. If you punch your calculator, you are going to get, so you are going to get 0.05. 0.05. So that is the average size of the grant materials used. That's the average size of the grant materials used. I think that's the question that I'm solving. And if you look at the question, that question carries 15 marks. So if you are able to solve this question in the exam hall, you have already had your 15 marks. Thank you very much. Please don't forget to click on the subscribe button and hit the notification bell to enhance the growth of the channel, and when I drop a new video, you will be able to see it. Thank you very much. Bye.